The Timeless Journey, a deep dive into time travel. Time travel, a concept that has intrigued the human mind for centuries. Since ancient times, we've wondered, is it possible to move beyond the constraints of the present, to leap forward into the future, or travel back to a long-lost past? Could we revisit the most significant moments in human history? Or perhaps change the course of our own lives? Today, we embark on a journey not just of imagination, but of science, exploring the possibilities, paradoxes, and philosophical dilemmas posed by the prospect of time travel. Time travel has long been a staple of science fiction, captivating audiences through books, films, and television. But while many might think of it as pure fantasy, there's an entire field of scientific inquiry that dares to ask, what if? Could time travel be more than just a figment of our imagination? Let's start by unpacking what we mean when we talk about time. What exactly is time? For centuries, we thought of time as an absolute, a continuous, ever-forward-moving river. But then, in the early 20th century, a physicist by the name of Albert Einstein revolutionized how we think about time with his theory of relativity. According to Einstein, time is not absolute. It's woven together with space, forming what we now call space-time. Einstein's theory showed us that time can stretch and compress, depending on the speed at which an object is moving relative to another. Time slows down as you approach the speed of light. This phenomenon is called time dilation. So, in a sense, time travel already happens, just not in the fantastical ways we typically envision. For astronauts on the International Space Station, time moves just a tiny bit slower than it does for those of us on Earth. They're traveling through time, just by fractions of a second. But does this give us hope for the kind of time travel where we leap hundreds or thousands of years into the future? Well, let's dive deeper. One of the most exciting prospects of time travel lies in the concept of wormholes. Wormholes are theoretical passages through space-time, shortcuts that could connect distant points in the universe. Think of space-time as a piece of paper. If you draw two dots on opposite sides of the paper, those dots represent two different points in space. Normally, you'd have to travel across the paper to get from one point to the other. But what if you could fold the paper so that the dots overlap? Suddenly, the distance between them is reduced to nothing. In theory, a wormhole could allow for similar shortcuts, not just through space, but through time as well. Wormholes were first predicted by Einstein and his colleague Nathan Rosen, which is why they're also called Einstein-Rosen bridges. But even though the math allows for their existence, we've never observed one. And if they do exist, we'd need exotic forms of energy, something called negative energy, to keep them stable. Without this, the wormhole would collapse in on itself before you could ever hope to travel through it. But let's imagine for a moment that wormholes are real, and we have the technology to harness them. What would it mean for our understanding of time? Could we travel back to the past? Or would we be limited to moving forward into the future? This is where things get tricky. If you could travel back in time, you might run into a famous paradox known as the grandfather paradox. The idea is simple. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never be born. But if you were never born, how could you have traveled back in time in the first place? The paradox highlights one of the major logical problems with backward time travel. How can cause and effect be maintained when you're tampering with the past? Some scientists argue that paradoxes like this mean backward time travel is impossible. Others suggest that it could work if we live in a multiverse. In this scenario, every decision we make creates a new, parallel universe. So if you go back in time and change something significant, you don't alter your original timeline. Instead, you create a new, alternate timeline where events unfold differently. The multiverse theory suggests that all possible outcomes of every action exist simultaneously in an infinite number of parallel universes. But even if backward time travel were possible, would it be ethical? Think about it. Imagine the temptation to go back and stop a disaster, or meet a historical figure like Leonardo da Vinci, or even fix a personal mistake. But what kind of unforeseen consequences might arise from such actions? If we changed one event, how would that ripple outward to affect others? The idea that a small change in the past could have far-reaching consequences is often referred to as the butterfly effect, popularized by chaos theory. Could the flap of a butterfly's wings in the past really lead to a hurricane in the future? Perhaps. Let's now turn our attention to the future. Traveling into the future is actually much more straightforward, at least theoretically. Thanks to time dilation, as predicted by Einstein, we know that if you travel close to the speed of light, time will pass much more slowly for you than for those back on Earth. So, you could leap into the future by moving at incredible speeds, or by orbiting a massive object, like a black hole, where the intense gravitational forces warp time. For example, if you spent a year near a black hole, decades or even centuries might pass for the rest of the universe. But what if we could travel farther into the future than our current technology allows? What kind of world would we find? Would humanity still be around? Would we have colonized other planets? Or perhaps even achieved immortality? Speculation about the future is rife with possibilities. One thing seems certain, though. If we ever achieve time travel, it would revolutionize our understanding of the universe and our place within it. Interestingly, the concept of time travel also forces us to confront our own mortality in a unique way. As human beings, we are bound by time. Our lives are a series of fleeting moments, and no matter how hard we try, we can never return to a moment once it's passed. Time travel offers a tantalizing possibility of escaping this fate, of revisiting our fondest memories, or correcting our biggest regrets. But should we? If we could live our lives over and over again, would it take away the beauty of our existence, which lies in its impermanence? These are questions that go beyond the realm of science and into philosophy, and they force us to reflect on what it means to live in the here and now. There's one more avenue of exploration we haven't discussed yet: quantum mechanics. In the world of quantum physics, particles behave in ways that seem to defy the laws of classical physics. They can exist in multiple states at once, a phenomenon known as superposition, and they can be entangled, meaning the state of one particle is instantaneously connected to the state of another, even across vast distances. Some physicists have speculated that the strange behaviors we observe in the quantum realm might one day provide the key to time travel. But we're still far from understanding how, or if, this could be achieved. So where does all of this leave us? Is time travel possible? In some ways, the answer is yes. Through the effects of time dilation, we know that it's possible to move into the future, though not nearly as dramatically as we might like. And while wormholes and quantum mechanics offer tantalizing hints at the possibility of more dramatic time travel, we're still a long way from turning these theories into reality. Ultimately, time travel remains one of the most profound and tantalizing mysteries of science. It challenges our understanding of the universe and forces us to confront deep questions about the nature of reality, causality, and free will. But even if we never crack the secret of time travel, the pursuit of this knowledge will continue to push the boundaries of science and philosophy alike. Perhaps one day we will unlock the doors of time, stepping through them to explore the past and the future firsthand. Until then, time remains our constant companion, elusive, yet ever-present. The clock keeps ticking, and our journey through time continues, 1 second at a time.